Hey guys, so yeah, this is the problem. This problem came in today's contest, and so close to like 35,000 people were taking part in the contest. Only 986 people could actually solve it, which is less than or like close to 3% of total people. So yeah, let's get started with this problem. And so like this problem uses dynamic programming. If you are seeing this problem for the first time, you can pause the video here and try to think of the solution. As you can see, like statement is pretty simple, but yeah, also I will provide the submission link also and the problem link in the description, so you can check out the problem from there also. First of all, as always in any problem, our first step is that we want to try to understand like what this line actually means. But yeah, at least for this problem it is pretty simple. Basically they are choosing a subsequence, and for they are counting consecutive pairs in that subsequence which are not equal, and they are saying we can at most have k such pairs. Alright, let's try to understand this line itself by some examples. Okay, let's see here. So if we have this subarray or like this array, let's say we are given this array and value of k is 2. So if we have one example, let's say if we choose these three elements, right, as subsequence 1 to 1, then how many consecutive pairs are there which are not equal? 1 and 2, 2 and 1, correct? So for this 1 to 1, our number of consecutive pairs which are not equal would be 2. For this, consecutive pairs would be just 1, because this pair is equal, these two are not equal. So if we choose this subsequence, consecutive pair would be only 1 consecutive pair which is not different. Alright, so we have the value of k equal to 2, so we can choose any of these subsequences. Subsequence means we can choose any element, it doesn't have to be consecutive. If you see here, we are for this one we are choosing this one and this one, this one, this one. So yeah, for this, for k value of k equal to 2, any of this subsequence would work. Why? For first one, let's see, one consecutive pair which is not equal, one consecutive pair which is not equal, so this last one is equal. Overall the answer is k is equal to 2. Basically maximum 2 consecutive pairs are there which are not equal, so the answer is 4, because we can have subsequence of maximum length 4. Let's look at one more example. If we have this array and k is equal to 0, if k is equal to 0, so it means we cannot even have one consecutive pair which is different, so we can only choose same elements. So yeah, basically only one is occurring twice, so we'll choose 1 and 1, and the answer is 2. Alright, so I hope the definition of this line or like what this line means is clear to you. Basically eventual goal is that we want to find maximum possible length of a good subsequence. Alright, let's look into what can be a dynamic programming state for this. Okay, so if this is the state, let's say dpij, and dpij means maximum length of good subsequence which is ending at ith index. Understand this carefully. dpij means maximum length of a good subsequence which is ending at I, and it have maximum different pairs j. So basically subsequence, the current subsequence is ending at I, and whatever we have chosen, different pairs, consecutive different pairs are not more than j, basically, correct? So what we can do is, if we, for now let's just assume that we are somehow able to calculate this. If we can calculate this for all value of I and j, value of I will go from 0 to n minus 1, which is all the index. value of j will go from 0 to k, because we cannot take more than k consecutive pairs. So that's what we got in. So for now, let's forget how we are going to calculate this dp, but I'm making a claim. If we can calculate this, and for all possible value of I and j, if we take maximum of all those value, then we would have our answer. Is that right? Yes, because we will take all subsequences which are ending at 0th index, first index, second index till n-1, and we will also take all possible values of k, and eventually we just need the maximum value only. Correct? So that claim is understandable, right? If we can calculate this dpij for all values, then we would be good. How to calculate this dpij? So let's see here. We iterate through I, jn1, j 0 to k, like we talked about. So currently we are at a state. So at present, what we are doing is we are trying to calculate dpij. Okay. Now look here. So basically, when we are at the I and j, we have filled all values where I is less than the current value and j is less than the current value, because we are doing this loop, right? So what we can do is, our last element of this active subsequence is nums I, right, which is the current element. So what we can do is we can try all possibilities for the second last element, right, which would be we go to the all previous indexes. P will go from 0 to I-1. Only main idea is that we have the last index according to definition of dpij. Last index of this current subsequence is I. We are trying to find the second last one. If this element is equal, then the answer for that value is be okay, dppj from there and one extra for this element. We are increasing the length. Okay, if some nuances are not clear by when we are understanding the theory, you don't have to care about that at that point, because at this point we are just trying to understand the algorithm. In the end, I will quickly look through the I will show you the code also, which would make it even clear if some nuance or some technical thing is not clear. Alright, so if those two values are equal, then we are not increasing the count of pair, correct? Because those two values are equal. So in our subsequence, the idea is we have this subsequence, let's say some numbers, and then last element is x, and if the current element also x, so whatever the value of j was still here, we are not increasing it because these two elements are equal. So that's why we take j as the same, right? If these two are not equal, which means that, let's say if this is y, other one is x, then we are increasing, right? So for that scenarios, we take j minus 1, because we are increasing the pair by 1, so we have to take j minus 1. So basically, if we iterate through this and take maximum of all of these value, then we would have the value for dpij, right? Because we have the last index, we are iterating through the second last index for all possible values of that, and whenever elements are equal, we take j, because we are not increasing the count. If elements are not equal, we take j minus 1, because now we are increasing the count, correct? So that's it, we are done. What would be the time complexity for this? You can try to think yourself. Yeah, I think I just showed it, but still you can try to think what would be the time complexity. It is simple, right? this loop is going n, this loop is going k times n into k, and then this loop is again going up to n times, so n square k. So yeah, that part is done. But if we look at the problem statement, 5 into 10 to the power 6, so it would become very large, right? So like this is actually good enough to pass third problem of the contest, which is the same problem with less hard constants. But yeah, can we make some optimization here which would make our solution even faster. And by the way, like one general tip about dynamic programming problems. So let's say you are trying to solve a dynamic programming problem and you can't find the most optimal DP, and you can find, you know, some sort of suboptimal DP. Maybe you have one extra factor of n, one extra factor of k, or stuff like that. Then generally a good advice can be try to write that on paper, or try to think deeply about how you would calculate it. Sometimes like what happens is that you can somehow, let's say you have 4 loops, right? Then after you see, okay, for calculating this I need to run this 4 loops. Sometimes you will see, okay, one loop can be replaced by some data structure or by some sort of technique, and then your suboptimal solution becomes optimal. For this also we will do this here. So we have this loop, right? If we look here carefully, for basically these are all the elements which are equal to current value, and these are all the elements which are not equal. So let's look at this one for like initially. So if we look here, I mean, actually I don't actually care about this index, right? P. I don't care which index this DP is coming from. Only thing I care about is that this is not equal. So basically, if I, instead of this, if I can store somehow what is the maximum till now for this j minus 1, then I am done, right? Index is irrelevant. We don't care for index. So if we can just store this value, we don't need to run this whole loop. I can just check this value and I'm done with this part of the loop in one instance, right? Try to focus again on this. So I actually don't care about which index this P is. I just care about this j minus 1, that consecutive pairs till now should not be more than j minus 1. So if we can just store this somehow, then we can just directly do this very quickly, right? Similarly for this one, again I don't care about this index. I only care about that this value is equal to num psi and this j. So in the same way, if I can store this, then I would be done. So let's assume if we are storing both of these in map, then this whole loop can be replaced by just map check. If you are using, let's say, ordered map, that will be log n, or if you are using unordered map, that could be close to constant time, right? So basically we can just replace this whole loop by these map checks. So the time complexity will become nk into whatever map you are using. Try to pause here or like repeat the last 1 minute of the video if you don't understand what we mean by this. But yeah, let's look at the code. If you are wondering about, okay, how do we calculate this, it would be actually pretty simple. This whole thing is just 10 lines of code and you will be amazed by the code here basically. Alright, so like this is just some clearing out part. Only these 10 lines or 15 lines are the code. We iterate from 1 to n, we iterate from 0 to k. This is the current max, which is basically, obviously from current position we can start a new subsequence. So this is equal to 1 at least, because we can start a new subsequence. Length of that will be at least 1, right? if we take this previous value same, right? So like this part, we have these two maps here. So if this value occurred till now, we take maximum, we check if this value occurred, we just update our current by 1 plus maximum till now. If it can be anything else, then we update current by maximum of 1 plus overall max. The only key idea, like we're talking about here, we are taking j minus 1. Why? Because this value is different from current. That's why in the previous state, compared to previous state, we are increasing the j value by 1. But in this one, that's not the case, so we are just taking the same j. Alright, then we are just updating both of those maps. We are taking max of answer, and yeah, that's it. We are done. And yes, one thing, this is a quiz to everyone. Why are we iterating from k to 0 and not 0 to k? Like if I just update this loop here from 0 to k, would everything work fine or not? Alright guys, hopefully you understood this algorithm. If not, comment on the video. I will try to clarify the doubts. I will attach the link of the problem and the code in the video. But yeah, let's like and subscribe to encourage me to like make more such videos. Okay,